So, here's the 7-1 homework, bless you. We've had a little bit of time to look at number 1, and I just kind of scrolled down to see number 2. Does anybody have any questions on 1 or 2? Okay, I'll leave it up for a second. Those of you on YouTube, feel free to pause it and check in, because we're gonna move probably a little quicker. All right, I'm gonna move on from this now, is that okay? The last one says your choice. I think a substitution is probably the best bet. So they're both equal to y, so you can just set the two x expressions equal to each other. I moved everything to one side. I solved, and then I plugged 0 in and 3 in, and I got 0 and 18. So yeah, if you missed 7-1, or if you were here yesterday, we didn't really learn that much. We started some basic matrices, which I hope to finish today. Anybody questions on this homework? If you're done, can you put your name on it, tear it out of your homework package, and pass it forward? If you did it online, is there a submission box online?
There is.
There is? Thank you so much. Sometimes I just don't know if I did it or not. All right, when you're done with that, make sure you get your notes out so we can do 7-2 notes. Thank you. Thank you. Okay. You still have yours for some reason, that's okay, just get it to me later. Okay, so we're gonna do a quick kind of talk about what we learned yesterday, and then we're gonna move on. I'm hoping to get through all of 7-2, and we'll decide if that's an ambitious goal or if it's a reasonable goal. Okay. And actually, we did not do letter D yet, so I'm gonna fully erase that. Thank you. Yes, you may. So, if you weren't here yesterday, okay, this was some of our vocab that we learned. Those of you who are online, feel free to pause and look at this. Those of you in person, this is just some of our vocab. We're not going to do vocab on a test or quiz, but like, since this is very new to us, when I use the word matrix, I want you to know what I'm talking about. When I say dimensions, when I say square, when I say scalar, those are just words I want you to know what I'm talking about as I use them. We have not done the last 3 yet, so as we hit those, we will do those vocab. So until I need to tell you about them, I'm not going to worry about it. Okay. Again, a couple just like verbal reminders from yesterday. These matrices is just the organization or the arrangement of the numbers. And we do rows, which is the horizontal number, by column. So that's the vertical amount. And so that's what these little dimensions at the top are. When we add or subtract matrices together, I rewrite them, and then you combine the elements or the numbers that are in the same position. They also must have the same dimension, because you have to add or subtract the numbers that are in the same spot. So like if I look on number like A and B, notice, I guess C didn't work because the dimensions weren't the same. But on A and B, you can kind of follow the colors and see how they match up. So like 1 and 6 were both in the top left, so they add together to be the new top left. -2 and 3 are in the top right. They add together to be 1, which is also in the top right. Okay. We had this number in front of B, matrix B and letter B. Do you guys remember what the word for that is? Scalar. Very good. So when you have a number that's being multiplied by a matrix, that's called our scalar. And then same thing, we looked at it in letter C, but then once I started solving it, I realized that I didn't have like numbers in all the same spots. They were not the same dimension, so number C did not work. So there was no answer for letter C, it just was a no. You can say NA, you can say doesn't work, can't do, error, you can write whatever you want, but there is no answer for that.
Do you even have to write out the matrix if we know it's not?
Good point, you do not. So I showed you that you could forget that you needed the same dimension and still know that it wasn't going to work, but you could immediately look at dimensions and say it's not going to work and just have not had any of that work and just written down. Okay, today I'm going to teach you about multiplying. F period, you guys have already learned this, but C period, I want you to write this down. All of these problems, D, E, F, H are all multiplying problems. And so I want us to write this multiplication. It's the number of columns in the first matrix that must equal the number of rows in the second matrix. Okay. You can only multiply when the number of columns in the first matrix matches the number of rows in the second matrix. Number of columns in the first matrix must match the number of rows in the second matrix. Now, once we do this, I'm going to show you kind of an easier way of knowing that, but this is like the longer explanation. If I look, letter D says we're going to multiply matrix A and B together. I can't see it on my screen right now, but what's the dimensions for matrix A? 2 by 2. And what's the dimensions for matrix B? 2 by 2. Okay. Now, remember that when we list the dimensions, it's row is the first number and column is the second number. So I'm essentially looking at the second number in the first dimension and the first number in the second dimension. My question always is, do those match? And if they match, I can multiply them together. So see how they're both 2? I can multiply this together. Because those match, essentially when I multiply, the middle numbers go away and my new dimension for my matrix is going to be a 2 by 2. That's kind of cool so that I already know what I'm going to get when I solve this out. Okay. Because their middle numbers match, I'm going to be able to multiply it and it's going to be a 2 by 2 matrix. You might just be like, Miss White, there's just a bunch of 2s and 2s and 2s. In a second, we'll have different dimensions and I'll show you how it works. And that might be a little bit easier to understand. Okay, now just like we did with adding and subtracting, let's rewrite matrix A and B down on our paper. So I'm gonna write matrix A here, which is 1, -2, 3, and 5, times matrix B, which is 6 and 3 and 0 and -4. And that is going to give me a new 2 by 2 matrix. Okay, so I'm just gonna have that set up. This is a little hard to learn just on video, which is why I'm glad we get to do it in person, and that's why I pushed to do it with F period yesterday. It's not crazy, but it's just like, I don't know, it's just a little, you have to be there to do it. Okay, first thing we're gonna do is we are gonna take the first row and multiply it by the first column, and that's gonna give me the element that goes in the first row, first column of my new matrix. Okay. Multiply first row by first column. I'm going to multiply the first things together. I literally take my fingers and I go 1 times 6. And then plus -2 times 0. And let me actually scroll this down. This may or may not be helpful to you, but at this point, I'm willing to do anything to help you know. I literally take my 2 fingers and I put them on the first number I see, and I'm going to multiply 1 times 6. Plus, and I'm going to move my fingers, multiply those 2 numbers together. 1 times 6 plus -2 times 0. Okay, everybody good with that? Okay, now to find the number that goes in the first column, or first row, but second column, I'm going to multiply by the first row and the second column. Okay, so now in my head, I'm doing 1 times 3 plus -2 times -4. Now, you see I'm writing a bunch of those things. You can do those in your head. I'm just really being extra to really show a point right now. Okay, bless you. Bless you. All right, now I'm gonna go, this is now my second row and it's my first column. So I'm gonna multiply by my second row and my first column. So again, I'll do my 3 times 6, I can't reach that, and then 5 times 0. 3 times 6, 5 times 0. And then the last spot that we haven't touched yet is still my second row, it's my second column. So my second row times my second column. So now I'm gonna do 3 times 3 plus 5 times -4. You guys okay with that so far? You don't have to be able to do this by yourself, but does everyone kind of follow with what I'm doing? Okay, now we're gonna do those multiplying things out. You could have skipped this middle step. You've maybe already done this, but I haven't. So I'm gonna do 1 times 6 is 6, plus -2 times 0 is 0. I'm gonna do 1 times 3 is 3, plus -2 times -4 is 8. 6 times 3 is 18, plus 5 times 0 is 0. And then 3 times 3 is 9, plus 5 times -4 is -20. And then my answer here is gonna be 6, 11, 18, -11. Did I do that right? Is that what you guys got? That's what I got. Okay. Kind of a lot, but nothing too hard. Should we do a few more of these? Okay, let's keep practicing this out. Okay, so we're gonna jump down and we're gonna do DC. Before I start copying them out, let's see if my dimensions work, okay? What are my dimensions for DC?
3 by 3, 2 by 3.
D is a 2 by 3. And we see D first, so we're gonna do that, and then C is a 3 by 3, right? So 2 by 3 and a 3 by 3. Do my middle numbers match? Yes. Can I multiply them? Yes. What is the dimension of my new matrix gonna be?
2 by 3.
2 by 3, very good. The middle cancels out, it's gonna be a 2 by 3. So I'm gonna set that up. I'm gonna copy D and C, and I'm gonna set up a new 2 by 3 matrix so I have places to plug everything in. Okay. D is gonna be 2, -1, 3, 5, 1, 4. C is gonna be 1, -1, 2, 0, 3, -1, 1, 4, 0. And then I'm gonna get a 2 by 3 set up. 1, 2, 3, 1, 2. I will tell you that we will be able to put these in the calculator shortly. So not today, I don't think, but in the next few days, I'm gonna teach you how to enter all this in the calculator, which makes it a little bit easier. We won't do much more than 3s. Because once you start doing like 4s and 5s, it just gets getting really, really big for no good reason. So at a certain point, we'll start putting it in the calculator. But this is stuff that we can definitely do by hand, so we're gonna do that. Okay. Are we ready to start multiplying? Okay, so my first spot is the first row, first column. So I'm gonna multiply by first row, first column. And I've got to do both of those, okay? And I actually might kind of skip that first step that I did. I'm gonna do a little bit in my head. So I'm gonna do 2 times 1 is gonna be 2. -1 times 0 is gonna be 0, and then 3 times 1 is 3. Okay. Now we can do first row, second column. So first row, second column. So now I'll do 2 times -1 is -2, -1 times 3 is -3, 3 times 4 is 12. Everyone hanging with me? Okay, next I'm still in the first row, but now I'm in the last column. I'm in the third column. So I'm gonna do first row and I'm gonna do last column. So 2 times 2 is 4, -1 times -1 is 1, and then 3 times 0 is 0. And again, I'll try and put this low enough. So again, in my head, I'm doing this. I'm doing 2 times 2 plus -1 times -1 plus 3 times 0. Okay. Shall we do the next row? Okay, now I'm in the second row. Now I'm in the second row and I'm gonna do the first column. So second row, first column goes right there. 5 times 1 is 5, 1 times 0 is 0, 4 times 1 is 4. Bless you. Now I'm gonna do second row, second column. That's the next spot, second row, second column. 5 times -1 is -5, 1 times 3 is 3, and 4 times 4 is 16. And then last but not least, I will do last row, last column, or second row, third column. That's that last spot. 5 times 2 is 10, 1 times -1 is -1, 4 times 0 is 0. All right, now you do your addition, subtraction, all that stuff in each box. So I'm gonna do 2 plus 0 plus 3 is 5, -2 plus -3 plus 12 is 7. 4 plus 1 plus 0 is 5. 5 plus 0 plus 4 is 9. -5 plus 3 plus 16 is 14. And then 10 plus -1 plus 0 is 9. All right. Are we feeling okay so far? Okay, let's keep going. Let's look at the next one. Next one's AC. Before I do anything, let's check our dimensions, right? What's A's dimension? 2 by 2. What's C's dimension? Can I multiply those together? No. That's an okay answer. It's okay to get no as your answer. That's okay. But I love that we checked our dimension. We didn't try and plug anything in. I know that those middle numbers should be the same and they're not the same. So that means it won't work. All right, nice. That's one less problem we have to do. Okay. I'm gonna get down to letter G, and this has A, and then the A has like an exponent of a T times B. T is something special we haven't talked about yet. T is what we call transpose. There's a vocab word for that on the other side, but I think it's nice to just kind of put this information right next to where we're about to use it. Transpose is a like operation we do with these matrices. Let's say that our original matrix was A, B, C, D. Okay. If I started with A, B, C, D, or 1, 2, 3, 4, I don't care what you want to think about. Transpose means that I'm going to flip everything across the diagonal. So now when I transpose it, the diagonal right here is AD. And whenever I talk about the diagonal, we're always going to go from like the top left down to the bottom right. So my diagonal is AD. The diagonal stays the same, and then any other element flips spots. So it flips across the diagonal. So instead of A, B, C, D, it's going to go A, C, B, D. So A and D are in the same spot. B and C just have flipped spots. Flipping spots. Okay, so let's take A, the matrix that was given to us. Great, we'll question the one that is has the exponent. In terms of A and B. Yep, since think about T being an exponent behind A, so the matrix in front of it is the one we're going to transpose. So let's go transpose A. You're welcome to rewrite A as normal, or I can just use what I know A to be and just flip it along the diagonal. So I know A is 1, -2, 3, 5. The diagonal 1, 5 is going to stay the same, and we're going to flip -2 and 3 to the other side. And actually, just for sake of all of you guys, I'll actually do it a little bit the long way. I'll write the normal. This is what was given to us. This is A. And so when I do A transpose, it becomes 1, 3, -2, 5. Yes, Carolyn. You always keep the diagonal the same and then flip the other ones that are not on the diagonal. So in that case, yes, the top right one and the bottom left one flip. Okay. So now we're gonna take that and we're gonna multiply it by B. And we know B is 630 -4. And I'll just label it as B just in case we're confused. And we're gonna multiply this just like we've multiplied the last two examples, okay? I'm gonna be quiet, I'm gonna do a little highlight, you can check in with me, but I'm gonna be quiet, let's see if you can multiply just like I taught you. All right, there's my answer. Double check, does that look good to you guys? Let's learn one more new thing and then I think it'll be time for lunch, okay? This next little bit, it says DETA. And if you notice, the next one says DETB, and if we flip the paper over, we got DETC and DETD. So we've got to learn this DET. That is this word right here, the determinant, okay? So we're gonna just make a little note off to the side over here. So DET is equal to the determinant. Okay. Determinants only happen in squares. They're only in square matrices. If I ask you for a determinant of a not square matrix, you say no. You say it doesn't work, I can't do that, it doesn't exist. It only works in squares. And we can do it, I will show you how to do it by hand for a 3x3, but I am expecting you for a quiz to know how to do it by hand only for a 2x2. Actually, today might be the day I show you how to do a couple things in the calculator, because you can do determinants in the calculator of anything bigger, but you are expected to know how to do it by hand for a 2x2. Okay. The determinant is actually just one number that comes from your matrix. So let's use the original matrix we used in the last example. I'm going to rewrite that original matrix right here. So let's say this is my original. It's A, B, C, D. Okay. We get the determinant by multiplying the numbers on the diagonal together. So the determinant is equal to A times D. And then minus the other diagonal, B times C. Now, could you do A times D or D times A? I don't really care. Multiplication is commutative, so it doesn't matter. But we're multiplying the two diagonals together, A times D and B times C. And whatever number that gets when we multiply and minus them, that is your determinant. Okay. So let's do letter A really quick. Let's do determinant of A. So I know A, look back at the top of your paper. It's 1, -2, 3, 5. Okay, so I'm going to multiply A times D, so 1 times 5. And I may even write it like that. I'm going to go 1 times 5, and then I'm going to say minus, and then I'm going to multiply the other two numbers, 3 times -2 or -2 times 3. I don't care what order you write them in. Okay, 1 times 5 is 5. Now, minus 3 times -2 will end up becoming a +6. And what's 5 plus 6? 11. 11 is your determinant. Okay, that's it. All right, I think we're cruising. We got a lot left to do after lunch, but we are doing good work. Go ahead and go to lunch. I will see you come back at 12:45.
All right, part one.